Today's exercise is secrets. The previous episode identified documentation as the first-class citizen. Secrets exposes that functions are also first-class citizens. We've seen public and private named functions. In secrets, we'll learn about anonymous functions and how functions can be created and passed around like variables. This exercise also introduces the bitwise module, and it fits with the theme of creating secrets, but the big takeaway is anonymous functions. We're going to use AI Studio again as our trainer. We'll use the same settings as before, but I'll pick Sharon as the voice. All right, in aistudio.google.com, we'll start a live session. We'll go to Stream on the left. We'll make sure we have picked the native audio dialogue model. We'll turn on turn coverage. We'll turn on effective dialogue, and we're going to pick Sharon as our voice. And then we share our screen. Hi Gemini, I'm working on the secrets exercise in the Elixir track on exorcism.org, and I'd like you to be my coding mentor.
Hello. I can definitely help you with that. Let's work through the secrets exercise together. What's the first step you're looking at?
Well, first I need to understand about anonymous functions, how we define them and how we use them.
Okay. Anonymous functions in Elixir are defined using the fn keyword, followed by the arguments, a dash arrow key symbol, and then the function body, ending with end. You can assign them to variables to call them later. Does that make sense?
It does. And how would I use one if I
Great.
had it assigned?
To use an assigned anonymous function, you call it like any other function, using the variable name followed by a dot and then the arguments in parentheses. For example, if the function is in a variable called function variable, you would call it like function variable dot and then the arguments, if it takes no arguments. If it takes arguments, you put them inside the parentheses.
This exercise also suggests that there's a shorthand notation relative to the function and end block.
Yes, there is a shorthand notation. You can use the ampersand symbol followed by the parentheses, like n ampersand. Inside the parentheses, you can use the &1, &2, and so on to refer to the first, second, and subsequent arguments. This was useful for simple functions.
Why does the secrets exercise talk about bit manipulation?
The secrets exercise might discuss bit manipulation because it's often used in tasks related to encoding, decoding, or encrypting data, which are common concepts when dealing with secrets. Bitwise operations allow for low-level manipulation of data, which can be important for these types of operations.
All right, and it looks like we've made it down to the instructions, so let's hop into the editor and see if we can solve the exercise.
Great! Let's jump into the editor and start solving the secrets exercise. It sounds like a fun challenge working with anonymous functions and bit manipulation. Let me know what the first task is.
All right, it says to create an adder, create secrets underscore add, and it should return a function which takes one argument and then adds it to the argument passed into the secret add.
Okay, so we need to create a function that returns another function which adds two numbers together. Got it. Let's try defining the secret underscore add function to return an anonymous function that adds the addition. How does that sound?
I think that sounds right. So we'll use the fn keyword for this one. It's going to take in a number, let's call it x, and it's supposed to return x plus the secret.
Exactly. Using the fn keyword to define the anonymous function and having it return x plus the secret should work perfectly for creating the adder function. Let's see if the test passed with that code.
It does. So we can move on to secret subtract.
Great. For secret subtract, you'll need to create another anonymous function that takes an input number and subtracts the secret from it. How would you define that function?
Let's try the shorthand syntax for this one.
Perfect. The secret and function shorthand syntax is a concise way to define the subtractor function. It should work correctly subtract the secret from the input number. Let's run the test to confirm.
All right, that passed also.
Excellent. 2 tasks completed. Now, for secret multiply, you'll need to create an anonymous function that multiplies the input number by the secret. How would you implement that?
I liked the shorthand syntax for these short functions, and I liked it so much that I felt like we should also use the shorthand notation for the secret multiply function itself. How does that look?
That looks great. The and, at secret, multiply secret shorthand is a perfect way to define the multiplier function. It's concise and clearly expresses the multiplication operation. Let's try running the tests to see if it passes.
That also passed.
Fantastic! 3 functions completed successfully. Now, for secret divide, you'll need to create an anonymous function that divides the input number by the secret. Remember to consider the order of division. How will you implement that?
Well, I think we would use if we kept with the shorthand notation, we would take the first argument, &1, and divide it by secret.
That sounds like a good approach. Using the shorthand notation with &1 divided by secret should work perfectly. Go ahead and implement that. Then run the tests to see if it passes.
Oh, our tests failed.
It seems the division wasn't quite right. Let's take another look at the task description. It mentions using integer division. In Elixir, you can achieve that with the function div. Try modifying your anonymous function to use div instead of divide. How will that look?
Ah, much better.
Excellent. Using integer division with div was the key. Now you've successfully implemented the secret divide function. What's the next task on the list?
Where did that div function come from?
The div function is a standard integer division function in Elixir. It performs division but returns only the integer part of the quotient, discarding any remainder. It's useful when you need the whole number result of a division.
Yes, but I didn't define it here anywhere. Is it just part of the language?
Yes, that's correct. Div is a built-in function in Elixir, so you don't need to define it yourself. It's part of the core language for performing integer division. You can use it directly.
All right, so I've jumped ahead to the secret AND. This is wanting us to do a bitwise AND operation with the argument passed in the secret, and I think that looks right.
Bitwise AND, huh? That sounds like a specific operation. What exactly does the amper operator do in this context?
Yeah, so this is the capture operator, right? The first and it says this is going to be a function. It's the bitwise band function out of the bitwise module. It's going to use the first argument along with the secret.
Ah, I see. So the AND is used to capture the function itself, and the AND1 refers to the first argument passed to that function. That makes sense. It's like creating a specialized version of the bitwise AND operation. Did the test pass for this task?
It did, so I'm moving on to the secret XOR function.
Okay, and what does the ampersand operator do for the secret underscore XOR function? Is it a similar bitwise operation?
It is, but uses the BXOR function.
Got it. So it's the bitwise XOR operation using the ampersand XOR operator, and that seems to be what the task requires?
It does. The test passes.
Excellent. It sounds like you've correctly implemented both the secret underscore and secret underscore XOR functions. What's the next task?
Create a function combiner. So we are supposed to return a function which takes one argument and applies it to the two functions passed in. This one's different.
A function combiner, you say? That sounds like you need to create a function that takes two other functions and an argument and then applies those functions to the argument. How do you plan to do that?
Well, I think here secret function 1 and secret function 2 are the two functions that we need to use. And I want to use the fn keyword to say that we're going to call that argument x. So we call secret function 1, and then I think this is where we need that dot notation and pass in the parameter x.
Okay, so...
No, go ahead. I wanted to know if that seemed right so far.
Yes, using fn x to define an anonymous function that takes one argument, x, is correct. And then calling secret underscore function 1 with x using the dot notation is also fine. What's the next step you're thinking of?
And then I think we pipe the answer from secret function 1 into secret function 2.
That sounds like a good plan. How are you planning to pipe the result from secret function 1 into secret function 2?
Using the Elixir pipe operator like this.
Excellent. That looks like a clean way to chain the functions together in Elixir. Have you tried running the tests yet to see if it works as expected?
Yes, all tests pass.
That's fantastic. It seems like you've successfully implemented the function combiner using the pipe operator. Great job!
Thank you. Thank you for your help.
You're very welcome. I'm glad I could help. Let me know if you have any more questions as you continue.
Here's some final notes. If I were doing this more professionally, I would make these consistent. These first ones are very short, and so they'll make it perfect for one line and the capture shorthand. I would be inclined to leave this last one this way, however, and then returning to that idea that documentation was first-class citizen, there should be documentation on all of these. Join me next time for the log levels exercise, where we learn about the Atom data type and conditional operations.